Look around you. Everything you see feels solid and real. The chair you sit on, the walls around you, the light in the room, all of it seems fixed, existing whether or not you are there to notice it. We naturally assume that the world is always there, independent of us. But quantum physics shows us that this assumption might not be true. At the smallest scales, reality behaves in a very strange way, and it seems to depend on whether or not it is observed. Scientists have been studying particles like electrons and photons for over 100 years. These tiny building blocks of the universe don't act like little balls flying around. Instead, they behave like waves that can be in many places at once, a state called superposition. It's only when we look at or measure these particles that they seem to choose a specific place or state. One of the most famous experiments that shows this is called the double-slit experiment. Imagine firing tiny particles, like electrons, at a wall with two small openings, or slits. When nobody watches which slit the electron goes through, the particles create a pattern on a screen behind the wall that looks like waves interfering with each other like ripples in a pond overlapping. This means each electron is behaving like a wave and somehow passes through both slits at the same time. But if we put detectors to watch which slit the electron goes through, the pattern changes completely. Instead of a wave-like pattern, the electrons behave like tiny solid balls, going through only one slit or the other. The very act of observing changes what happens. This is called wave function collapse. Before observation, the particle exists in all possible states at once. After observation, it settles on a single state. But what exactly counts as observation? Does it require a human watching, or is any interaction enough? Scientists have debated this for decades. Some say that any interaction with the environment counts as an observation, like a particle bumping into something else. Others suggest that consciousness, the mind, plays a special role. And some say we just have to accept that measurement causes collapse, even if we don't fully understand how. What's clear is that particles don't have definite properties until they are measured. This goes against the way we usually think about the world. We assume things exist with clear features, no matter what. But quantum physics tells us that, at the tiniest level, things are not fixed, they depend on being observed. This idea changes how we think about reality. It suggests the universe is not a simple, unchanging stage. Instead, it is more like a play that unfolds as it is watched. The observer, the person or device that measures, is part of the process, not just a passive onlooker. This is not just theory. Physicists have tested quantum mechanics again and again with extremely precise experiments. The results always match the strange predictions of the theory. These discoveries have practical uses too. Quantum computers use the principle of superposition to perform calculations that would take classical computers thousands of years. Quantum cryptography uses the unpredictability of measurements to create secure communication channels. Still, there are deep puzzles. If observation is necessary for reality, what about before there were observers? How did the universe exist before anything could observe it? These questions push science into new areas and even cross into philosophy. One idea is that the universe is always observing itself. Particles interact and measure each other constantly. This might count as observation, making consciousness unnecessary. Another idea is that our understanding of observation is incomplete, and new physics will one day explain it better. These questions challenge us to rethink the nature of existence itself. Reality might not be just a thing out there. It might be a process involving us, the observers. Superposition, wave function collapse, entanglement, all these quantum ideas reveal a universe much more interconnected and mysterious than we ever imagined. Take entanglement. This is when two particles become linked so strongly that measuring one instantly affects the other, no matter how far apart they are. Albert Einstein called this spooky action at a distance because it seems to break the rules of space and time. Experiments have confirmed entanglement many times. It means that parts of the universe can be deeply connected beyond what classical physics allows. This also means that observation can have surprising effects. It's not just about looking at things, but about how things relate to each other. These ideas lead to a new way of thinking. The universe is not made of isolated objects, but of relationships. We are not just isolated observers, but participants in a shared reality. Physicist John Archibald Wheeler famously said, "It from bit meaning that information and observation create reality itself. According to him, every particle, every event depends on observation, the act of gathering information. Quantum physics challenges us to see the world as a web of interactions, not just as things sitting still. The strange quantum behavior also helps explain why the world we see is stable and definite. When many particles interact with the environment, their quantum possibilities get washed out in a process called decoherence. This makes things look classical and predictable on large scales, even though the tiny parts remain quantum. This explains why we don't see cats that are both alive and dead, or objects in two places at once. Even with these explanations, the question remains, what exactly is observation? Is consciousness required? Could it be that reality itself depends on our minds? Scientists keep exploring these questions. New experiments push the boundaries, using larger and larger systems to test quantum effects. Whatever the answers, quantum physics shows us that the universe is stranger and more beautiful than we ever thought. We are not just watching the universe happen. We are part of it, helping shape reality by observing and interacting with it. This insight opens new paths for science and changes how we think about our place in the cosmos. Reality is not a fixed thing waiting to be discovered. It is something dynamic, unfolding through observation. We are not mere spectators. We are creators, participants in the ongoing story of the universe. Quantum physics teaches us to embrace mystery and wonder, to see the world as alive with possibility. It invites us to imagine a reality where observation and existence are inseparable. And in that lies one of the greatest and most exciting mysteries science has ever revealed.